All right. So welcome to our series of quadratic graphs. Now we're going to be looking at gradient. So now before we apply the gradient in quadratic graphs directly, we need to know what gradient is. So in your notes, you may want to write the topic gradient. So the gradient in maths is very much similar to the one we have in geo, right? Gradient is simply the steepness of a line or a slope, right? So we're gonna write our simple definition like gradient is the steepness of a slope or a line. So whenever you have a line, obviously you can try to describe the line by how steep it is. So if I have a line like this is not steep, it's a horizontal line. And for horizontal lines, the gradient is 0. But if I have a line like this, it's slanted. And you cannot tell the gradient like out of the box. You need to use a formula for you to calculate gradient. So now let's move on to the right-hand side here. We need to write the formula for gradient. So gradient in maths, it is represented by the letter m. So m is your gradient. And the way you calculate it is to use this formula. M is equal to y1 minus y2 over x1 minus x2, right? So this is the general formula for finding gradient. But bear in mind that a point A will be having the coordinates x1 and y1 for this case to work, and another point B will be having the coordinates x2 and y2. So for you to find gradient, you need 2 points. Maybe you can write it as a point, like to find gradient, you need what? You need 2 points. Okay, so for simplicity's sake, we're going to be using 2 points to find our gradient. This is going to be applied to general straight line graphs and also to quadratic graphs. So let me know once you've finished writing these notes. Are you almost done, Lisa?
Yes, sir.
All right. Okay. So let me quickly erase this left-hand side so that we look at an example. All right. Write example. So the first example 1. Okay. So find the gradient of a line passing through A is the first point. I'm gonna use just dummy values. Point A is 2 and 5, and point B is 7 and minus 3. So we want to try and find the gradient of that line. Remember, I told you that for you to find the gradient, you need 2 points. So in this question, we are given the 2 points. We're given that A is point defined by the coordinates 2, 5, and B is defined by 7 and minus 3. So now this is how you lay out your solution. The first thing that you do is to identify your points, and you write down your points. So I'm gonna Write the points down now. So A is 2, 5, and then B is 7 minus 3. Now, after writing down your points, you need to label your coordinates as x1, y1, x2, y2. Bear in mind that whenever you are doing your labeling, the ones must be on the same point, like x1 and y1 must be on the same point. They are both on A. So which means x2 and y2 will be on B. Now, there's no strict rule on how you can do this. If you want to interchange the letters x1 and y1 to make them be on point B, then it's up to you. You end up with the same answer. Are we together so far?
Yes, sir.
All right. So now after writing your points and highlighting x1, y1, x2, y2, you need to write your formula for gradient. So m is equal to y1 minus y2 over x1 minus x2. So m is going to be equal to, what is y1 in this case?
Is it 5?
Yes. So y1 is 5 minus, this minus is according to the formula for gradient. So minus, what is y2?
Minus 3.
Yes. So make sure you write the minus 3. Most students have a tendency of ignoring one of the signs. So make sure you write the minus 3. If you want to avoid confusion, you can actually put the y1 and y2 in brackets, just like what I did there. And then what is x1?
2.
Okay, good. And minus, I'm gonna do this practice of putting it in brackets for clarity. And then what is x2?
7.
Okay, good. That's fine. So now we just need to punch this in our calculator. If you're using a right view calculator, it makes it easier. So I don't have a calculator with me. I'm going to evaluate the numerator and the denominator. So if you punch in 5 minus minus 3, you're going to get 8. Divided by 2 minus 7, you're going to get minus what? Minus 5. So this will be your gradient. If you want to express it as a decimal, it's up to you, right? Can you quickly punch this in your calculator and tell me the answer as a decimal?
So it's minus 1.6.
Okay, minus 1.6. So this is our gradient. This is how steep that line is going to be, right?
Yes, sir.
Okay, so let's have another example, the last example before we dive into the graph. I'm going to erase this. And then we'll write example 2 here. Okay. Okay, blue example. So example 2. Find the gradient of a line passing through, I'm going to make it as hard as possible, minus 5 and 4, and 7 minus 3. Okay. So now we'll move on to our solution. Okay, I want you to be leading me as I write the solution. What's the first thing we need to do?
Write down the formula.
Okay, yes, writing down the formula is fine. So m equals what?
Y1 minus y2.
divided by
over x
mhm,
x2 over minus y2.
over x1 minus x2, like that, isn't it?
Oh,
You just
yes.
give the numerator first, and then after that, you give the denominator. So with time, you are going to be able to master the formula. Now,
Yes,
what's
sir.
left is to do the actual substitution, right? Remember, we're given 2 points. This guy and this guy, right? So which
Yes.
side do you want us to put the ones, x1 and y1? Where do you want us to put x1 and y1?
Oh, on the numbers.
Yes. Which number?
Is x1 going to be minus 5?
Yes. You can choose to make minus 5 for x1. So what will be y1?
Is it 4?
Yes. So this is your y1. And then you move on to your second point. You label x2 and what? y2.
Y2.
So x1 and y1 are together. x2 and y2 must be together as well. So now we do our substitution. What is y1 in this case?
4.
Yes. So we're going to write 4 minus, what is y2?
3.
It's not 3. Look closely.
Oh yeah, minus 3.
Yeah. So that's one of the common mistakes. So 4 minus minus 3, 2 negative signs there. And then divided by, what is x1?
Pardon, sir?
What is the value of x1?
Minus 5.
Yes, so we write minus 5 here, and minus according to the formula. And what about x2?
7. Plus 7.
Yes, so you just write it like that. And then you can use your calculator to evaluate this. And 4 minus minus 3, you just need to add that, you get a 7. And minus 5 minus 7, you get minus 12. Are we together?
Yes, sir.
And right from here, we found our what? Our gradient. So I'm going to give you an exercise just to practice on just finding the gradient using the formula. And yeah, it's not that hard. So now, normally in your exam, they will ask you to plot your graph. And then after plotting your graph, filling in the table of values, they might ask you to find gradient at a certain point. They won't give you the values of A and B or of any 2 points, but they'll ask you to find the gradient at a specific point. So let me quickly find another graph so that I illustrate this. Okay, so we can use this guy. Suppose you have completed your table of values and you have plotted your graph like this, right? Okay. One of the questions you may be asked, so A, find the gradient at x is equal to, let's just say 2. So this can be one of the questions you're going to be asked.
I'm sorry, I can't hear you.
All right, can you hear me now, Lisa?
Yes, yes, sir.
All right, perfect. So the first step, if you want to find gradient from a graph you've plotted, is to find the point on the graph, right? And
Yes,
then
sir.
after that, you draw a tangent at that point. Now, a tangent is a line that simply touches the curve. It doesn't go inside the curve, it simply kind of kisses the curve, right? So this is the tangent I'm drawing, the black tangent. You can use your ruler to draw a tangent. It's gonna be a line which is gonna kind of kiss the curve at exactly that point, the given point. So this will be our tangent. Are we together?
Yes, sir.
Okay, perfect. So now, the next thing we want to do is we have identified our point. Now let's pick 2 points on our tangent. Okay, right. So I'm gonna help you pick the points here. So you go to your tangent, you identify any 2 points, right? So usually, let's pick this point. This is 1 point on our tangent. We're gonna call it A. And the other point on our tangent, okay, let's extend it. And let's take this guy to be our B, isn't it? Any 2 points on the tangent. Can you tell me the coordinates of A, this point?
Is it 1 and like 2.5?
So it's gonna be 1.
1.
I made it deliberate, so we're gonna use rough values here. So here you can see the X value is 1, and also the Y value is 1. Are we together?
Yes, sir.
So our point A is 1 and 1. Now we move on to point B. What is gonna be the coordinates of point B?
Is it 5 and 8?
Yes, the X coordinate is 5 and the Y coordinate is 8, right? So we're using rough values here so that you can see clearly what's going on. But when you do this in your book, you need to make sure you are precise. You need to make sure you're using a ruler and you don't need to smudge like what I've been doing. You just draw your line or your tangent only once. So let me label this. This is a tangent. Are we together? So now
Yes,
we
sir.
have B. It's 5 and what? And 8. So now what we need to do is to use our formula. Remember, whenever you want to find gradient, you must use the formula for gradient. So let me use blue for this next part. So we have M is equal to what? Do you still remember the formula for gradient?
M is equals to y1
Mm-hmm.
minus y2
Mm-hmm.
over x2, no, x1 over, x1 minus x2.
Excellent. So you're gonna memorize it in time, and yeah, it's a good start. So now all you need to do is to do your substitution. But before you do that, to make sure that you don't mix your values, we need to label x1 and y1 on A. So this is going to be x1, y1. And then on B, we're going to have x2 and y2, isn't it?
Yes, sir.
And bear in mind that they can give you any letters, right? Your points can be P and Q, they can be anything. So I'm just using A and B because it's easy that way, right? But you can use any letters you want. Okay, so what is y1?
Y1 is 1.
Okay, so we're gonna write 1 minus, what is y2?
8.
Good. Divided by, what is
1 and 5.
1
Yeah,
minus
minus
5. Okay, can you use your calculator and tell me the answer there?
It's going to be minus 7 over 4.
Yes, minus 7 over minus 4. Are we together? 1 minus 8 is minus 7. 1 minus 5 is minus 4.
4.
So if you punch
Yes,
this
sir.
into your calculator, you're going to get a nice 7 over 4, or the decimal equivalent.
Yes, sir.
Okay. So this is how you find gradient whenever you have a what? A quadratic graph. So now, I'm going to move on to a different graph, and we'll try to find the gradient again. And then obviously I'm going to need to export this PDF file. I will send it to you so that you can stick it in your notebook.
So I have a question.
Yes.
How do you choose like the point on the tangent?
Okay. So there's no restriction to the points you can choose, right? But you need to make sure that you choose points that are easy to read.
Yes,
It
sir.
won't make sense for you to choose a point like this one. This can be hard to read. You don't know because there are some fractions, you know, it's 0 point something. So you try to avoid decimals where possible. So it's
Yes, sir.
advisable for you to choose a point where you have these bold lines on your graph paper, because you can easily read out the coordinates. That's 2 and 10 there. But if you pick something like this as your point, it's gonna give you a lot of trouble. It's gonna be giving you some decimals. So you can pick any points, but make sure you pick points that are easy to read.
Okay. Thank you, sir.
All right. So let's just do one more question, and I'll send you this because it will be much better for you to actually plot the graph and find the gradients. So let's see if we have another graph. Okay, we have this one. So now what we can do is let me erase this. We want to find the gradient here. Can you choose a point that you want us to find the gradient from? Any x value.
1.
Okay, that's
That's
fine.
1.
Okay, that's an interesting point. Okay, so we're going to find the gradient at 1. In this case, you don't need to find it. So part A, find gradient. at x is equal to 1. So you go to your graph. I hope I'm not breaking a lot. Okay, you go to your graph, you identify x as 1, and then you find x equal 1 in your graph. So this is gonna be the point. Are we together? But as you can see,
Yes, sir.
this is the tip of the graph. It's like a turning point. So at every turning point, the gradient is 0. So you can write this at the turning point. The gradient is 0. Okay, why? Let's use our previous method. So I said, if you have a curve and you want to find the gradient, you must draw a tangent, right? So I'm gonna draw the tangent, a line which is gonna kiss the graph at x equals 1. So this is our tangent. Can you see that the tangent is a straight line?
Yes, sir.
And if it's a straight line, it's not steep, the gradient is 0. But anyway, let's stay the course. Let's pick any points. Can you identify any points you want us to pick on the tangent? So this is our tangent. Can you identify any coordinates you want us to pick on the blue line or on the tangent to make our A and B?
3 and 2.
It's not gonna be 3 and 2. It's gonna be 3 and minus 3. Can you see that? Because
Oh,
here where I
yeah.
have highlighted it's minus 3, isn't it? The blue line is covering the minus 3 part. So this is
Yes,
gonna
sir.
be our A. It's 3 and minus 3. Can you pick any other point on the tangent?
-1 and -3.
Yes. So we have -1 and -3. That's gonna be our B. So let's write our formula. M equals what?
Y1 minus Y2 over X1 minus X2.
Okay, good. So now let's do our substitution, right? What I'm gonna do is we're going to label right in the graph where we highlighted our points. So this time let's make B the ones, X1 and Y1, and that will be X2 and Y2, right?
Yes, sir.
Okay, so what is Y1 in this case?
-3.
So we're gonna write -3 minus, what is Y2?
-3.
Okay, -3. Can you see I have a lot of negative signs? Make sure
Yes,
you
sir.
don't leave them out. If you have a negative, make sure you write it. Okay, and then now let's move on to the denominator, X1.
3.
X1 is not 3. Remember, this time I decided to put the ones on B. So X1 is -1, right?
Oh, yes.
Minus X2.
Sir?
What is X2?
Oh, it's 3.
Okay, good. So now let's plug this in our calculator and I need you to tell me the answer.
Okay, sir. It's going to be 0.
Yes, the final answer. Okay, the top part is 0 divided by what?
2 plus 2.
I need you to repunch the denominator in your calculator. make sure you include all signs.
Oh, -4.
Yes. So it's -1 minus 3, that's -4. And let's divide. 0 divided by -4.
0.
Okay. So that's the gradient. So if you encounter a question like this, where you are being asked to find the gradient at the turning point, and you know exactly that this is the turning point we're dealing with, you must know that the gradient is 0. No need to calculate it.
Yes, sir.
They will in fact ask you to state it, right?
Yes.
Okay, so that's fine. Now, I just need to introduce one more thing that's gonna be easy. Sometimes they'll ask you to use your graph to solve equations. So whenever you are solving equations with graph, you need to find the points of intersection, right?
Yes, sir.
So let me just write this. Okay. Right, sorry about that. Okay, so now I need you to write in your notes. I'm gonna be sending you this solving equations. Then you write this point. To solve f of x equals 0 or y equals 0 or x squared plus 4 equals 0. This can be any equation, right? Any equation. So whenever you are being asked to find the graph or what you have plotted is equal to 0, you are supposed to look at the point of intersection of the graph and the x-axis. Okay. Just look at the points of intersection of the graph and the x-axis. Okay. Are we together, Lisa?
Yes, sir.
Okay. So in this case, if you want to solve this equation is equal to 0, you go to where your graph crosses the x-axis and it's crossing the x-axis here and there. These two will be your answers, right? So in this case, our solution, we have x equals something and x equals something. Where is our graph crossing the x-axis? Let's start with this point. What is this point in terms of x?
Maybe 2.2.
Excellent. So it's going to be 2.2. And then we'll move on to the next part. What is this point?
So which one?
The first one where the graph is crossing the x-axis. Maybe let me try to zoom it in.
Oh, it's like 0.1.
0.2, but it's a negative, right? 0.1,
Oh, yeah.
0.2. So your answer will be what? Minus 0.2. Are we together?
Yes, sir.
So this is one of the easiest questions to solve. Whenever they give you a quadratic equation, they want you to solve it, and you have plotted the graph. Just go to where the graph is crossing the x-axis, and then you get your answer, right?
Yes, sir.
Okay, so I'm gonna export this and send it to you, and I'm gonna give you more work, like practice work. Make sure once you have completed it, you send it to me so that I can review it.
Yes, sir.
All right, so let's see this.